Hello there.
You move your mouse. You click. Instantly, a window opens, a link loads, a file saves. But what actually happens inside your computer in that split second? It is not magic. It is a precisely choreographed dance of electricity, logic, and billions of microscopic switches, all happening in nanoseconds. When you click, your mouse sends a signal through USB or wireless to your computer. This signal triggers what is called an interrupt. Think of an interrupt as a polite but urgent tap on the shoulder of your CPU, the central processing unit. The CPU pauses whatever it was doing, saves its current state, and asks, "What needs attention now?" The operating system steps in. It reads the click coordinates, where on the screen you clicked, and determines which application or window owns that spot. Maybe it is your browser, your file explorer, or a game. The OS translates your click into a specific instruction. Open this file, load this web page, select this item. Now the CPU gets to work. Inside the CPU, billions of transistors act as tiny switches, turning on and off to represent ones and zeros, binary code. Your click instruction is broken down into machine code, a series of simple operations the CPU understands. The CPU processes this through a four-stage pipeline: fetch, decode, execute, and store. First, fetch. The CPU retrieves the instruction from memory. Second, decode. It figures out what operation to perform: add two numbers, move data, compare values. Third, execute. The arithmetic logic unit, or ALU, carries out the operation at lightning speed. Fourth, store. The result is written back to a register or sent to memory. But the CPU does not work alone. It relies on a hierarchy of memory. The fastest is the register tiny storage right inside the CPU. Next is cache memory L1, L2, L3, which holds frequently used data so the CPU does not have to wait for slower RAM. If the data is not in cache, the CPU requests it from RAM, which is still fast but orders of magnitude slower than cache. While the CPU computes, it may also communicate with other components. If your click loads a web page, the CPU instructs the network card to send a request. If it opens a file, the CPU tells the storage drive to retrieve data. All of this coordination happens through the motherboard's buses, high-speed pathways for data. Once the CPU finishes its task, it sends a signal to the graphics processor to update what you see on screen. Pixels change. A new window appears. A button highlights. All of this, from click to visual feedback, typically takes less than 100 milliseconds. That is faster than the blink of an eye. Key takeaways. Your click triggers an interrupt that redirects the CPU. The CPU processes instructions through fetch, decode, execute, and store. Memory hierarchy registers cache, RAM, keeps data flowing fast. The CPU coordinates with other hardware to complete your request. And the entire cycle is optimized for speed, because even a millisecond of delay feels slow to you. Next time you click, remember, beneath that simple action lies a universe of coordinated complexity. Billions of transistors switching, millions of instructions per second, all to give you the illusion of instant response. Quick question. Did you know your CPU can handle billions of instructions per second? What is one tech process you would like us to explain next? Let me know below. If you found this helpful, subscribe for more simple explainers on how your devices actually work.